This is a video for AQA Further Pure Mathematics, Calculus section 1.1, where we're introducing the idea of volumes of revolution. You will have met that the area under a curve can be found by integration, and that it is really a summation of lots of rectangles, or the limit of lots of rectangles, as the width of the rectangle becomes smaller and smaller. So if we look at this rectangle here, we see that it has a relatively large width, and at the top there's quite an error in the size. However, as the rectangle width becomes smaller and smaller, then that error reduces, and we say that in the limit the summation becomes an integral. So here you can see one where the rectangles have been drawn actually above the curve, and there are 5 rectangles, so these are all over estimates. If we increase the number of rectangles, here we have 20 rectangles in this one, then you can see that that error is going to be much less. Here then we've got a rectangle of width delta x, and we can say that the height is f of x, so therefore the area of this rectangle is f of x multiplied by delta x. So the area of the graph between x is equal to a and x is equal to b then will be the sum of all of these rectangles. So it will be the sum from x equals a up to x equals b of all of these little delta a's. So that implies that the area is approximately equal to the sum from x equal to a up to b of f of x delta x. And then in the limit, the area will be equal to the limit as that delta x approaches 0 of the sum from x equals a up to b and in the limit we say that delta x approaches dx, if you like, in terms of the integral. So this limit is equal to an integral of x equal to a up to x equal to b of f of x dx. So that's the idea of a limiting process producing an integral. We can develop this idea into now finding volumes of objects where the volume has been produced by this curve f of x rotating around the x-axis. So if we imagine here an axis going through here, we don't imagine that's the x-axis, and we now rotate this around that axis, then we produce like a shape which would be rather like a vase on its side. So if I try and illustrate that, it would be this sort of shape. Not easy to draw in paper, but there we are. There's a rough idea of the shape we would get. Now this volume here is what's called a volume of revolution. And you can see here the idea of the volume being produced instead of by rectangles. Those rectangles, when they revolve around the axis, are cylinders or disc shape. So we now have a cylinder of width delta x, but it has an area here, so therefore a volume. The volume will be equal to the area of the disk multiplied by delta x. And it's this idea that we'll investigate in the next video, so volumes of revolution.